All right, this lesson is continuing what we started on Friday with simplifying radicals. And again, I said the reason we were learning this is that down the road, you're going to need to be able to do simplest radical form, especially when you get to geometry, and you'll be working with square roots a lot when you're doing the Pythagorean theorem, which you all know, a squared plus b squared is c squared. You end up taking a lot of square roots, and your teacher's not usually going to want you to leave it like square root of 40. They're going to want you to simplify that to 2 root 10. And so that skill is what you're going to learn in this lesson. Okay, so we'll go back to starting with numbers that don't have any variables attached. And we talked about how would you simplify the square root of 75. Well, if it was a perfect square, we could just be done, right? Square root of 36 we know is just 6. That's easy because 6 squared is 36. And so a square root, undoes a square in a sense. So what we want to do is we want to look for perfect squares that go into a number and pull those out. Okay, right? 6 times 6 is a perfect square, so this just cancels out nicely. So we're going to do the same thing now for 75. Okay, and the easiest thing to do is write out a factor tree to figure out its prime factorization. So remember, we look for things that are prime, 2, 3, 5, 7, and so on. And we keep breaking numbers down until we only have primes remaining. And then we rewrite that. Okay. And then what we do is we look for pairs of things that are the same. So in this case, we have a pair of 5s. And for everything that I circle, I put 1 on the outside. Okay, so again, what you're really doing is like 5 times 5 is 5 squared. And you're saying, okay, when I take the square root of that, it just becomes 5. Okay, we can't take the square root of 3, right? That would be some decimal. So we're just going to leave that alone. So we're going to pull that out. And when you take a square root of a pair, it turns into just a single copy. All right, and the 3 stays behind, and we are done. And that is your answer. And that, again, that's how many teachers down the road are going to want you to present your answer. Okay, so we'll do another example. I'll do 27, and then you can try the others, or feel free to pause at any point if you want to try these yourself. 27, okay, make a factor tree. 3 goes in 9 times, which splits into 3 times 3. Okay, so this is 3 copies of 3. Circle a pair. And for each pair, pull out 1 copy. So these go away, but there's still 1 3 left behind. And you're done. Okay, you may want to try 32 and 128 yourself. You end up getting a lot of 2s with these. You can break it down. I just happen to know from doing the factor tree previously a bunch of times that this is going to be 5 2s. Okay, circle a pair, circle another pair. Now for each of these, you pull that to the front, right? 1 copy to the front, 1 copy to the front. For each thing you circle, pull 1 2 out. So you started with 4 2s, you end up with 2 2s, and then you're still multiplying even when you pull them out. Okay, you didn't circle one of the 2s, so that stays behind, and now clean this up. 2 times 2 is 4, and you win. You are done. 128, again, you can do the whole tree out. It's a big one. There's a lot of 2s that go into this. In fact, there are 7 of them. 1, 2, 3, 4, 5, 6, 7 2s. But we circle our pairs. 1, 2, 3, and then pull those out. So pull 1, 2, 3. Oops, sorry. Saying one thing, writing another. There we go. Pull each one of those. You pull 1 copy for each thing you circled, and then there's a 2 left behind. 2 times 2 times 2 is 8. And we're done. Okay, so with numbers, we factor them out. We find common factors, and then we pull out pairs of common things. When you have variables, it's not any harder because a variable really just stands for some number, so we're still going to pull out pairs of x's or y's or whatever they happen to be. Okay, so we're going to look at this example now. 40x cubed. Again, I'm going to write this in fully factored form. You will still make factor trees for the numbers if you need to. Okay, so 2 and 20, 2 and 10, 2 and 5. Okay, so I'm going to write that out. 2 times 2 times 2 times 5. Now, x is really, right, x cubed, x times x times x. Do the same thing, right? Look for pairs of things that are the same. So here we have a pair of 2's. Okay, there's another 2 that doesn't pair up with anything. There's a 5 that doesn't pair up with anything, but there are 2 x's. Anything you circled comes to the outside. Okay, so now I'm going to write a radical. Anything I didn't circle stays behind. So some students like to start with that, right? I didn't circle a 2, I didn't circle a 5, and I didn't circle an x. So let's leave those behind, and this is all multiplied together. And then for each pair, pull out one copy of those things. Okay, 2 times x is just 2x, and 2 times 5 is 10x, and you're done. Try that yourself now. Okay, or you can watch me do it in a moment. Okay, so 75 I'm going to write out. I happen to know that it is 3 times 5 times 5 from before. And x times x times x times x times x, right? There are 5 copies. Circle a pair of 5's, a pair of x's, and another pair of x's. So on the inside, right, we didn't circle a 3 and we didn't circle an x. On the outside, we circled a 5 and an x and an x, and all that is multiplied together. X times x is x squared. And we're done. Okay, one more example if you want to try that. Give you a moment and then I'll catch up with you. Okay, so 20 factors out into 2 times 5, and then again 5 copies of x. Circle your pairs. 5x left behind. 2x squared on the outside. And you're done. Okay, that's really the skill. Now, beyond square roots, sometimes you will also see what are called cube roots. Cube roots are used when we're doing volume sometimes in geometry. Instead of undoing something squared, like a square root, okay, it undoes something cubed. And there are roots beyond. You can do a 4th root or a 5th root or a 10th root, 100th root. But usually in high school, you would only see square roots and cube roots. So we'll work with those most often. Okay, you do the same thing. You're going to start by writing it out. So 24 is 2 times 2 times 2 times 3. And then x, write out 4 copies of x. Okay, but instead of looking for pairs, like a square root, okay, we're going to circle 3 of a kind. So we're looking, this number tells us how many things to circle. Okay, so we circled 2 times 2 times 2. Again, really that's 2 cubed. And then we're taking a cube root, so that's going to cancel out and just leave us with a single 2 remaining. Okay, so that's why we circle 3 things. Okay, and there's a 3 here, we leave that alone, and there are 3 x's. Okay, now we do the same thing. Write the radical. That 3 matters. Okay, you need to show that it's a cube root. You just write it. Some textbooks will put it here. Some textbooks will put it more like next to the symbol. Doesn't really matter. Just needs to be there. You didn't circle a 3 and an x, so put that here. You circled 1 3 of a kind, so put a 2. And 1 3 of a kind, so put an x, and you're done. Okay, a couple more examples. You may want to try these yourself. The first one is a cube root. The second one is a 4th root, but you're just going to do the same thing. Right here, you're looking for 3 of a kind. And here you are looking for 4 of a kind. Okay, so the number tells you how many things to circle. So if you want to try it, go ahead, pause the video, and I'll catch up with you in a moment. Okay, so 54 is, let's see, 27 times 2. So 3, 3, 3, 2. And then x, 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 x. There we go. Okay, circle 3 of a kinds, 3 3s, 3 x's. On the inside, right, we did not circle 2 x's, so that's x squared, and we didn't circle a 2. We did circle a 3, and we did circle an x. And that's our final answer. Okay, for the last one, the fourth root. Okay, 32 is 5 2's when you factor it out. And yeah, it's a lot of x's to write, unfortunately. But that's all 9 of them. Circle your pairs. Well, not pairs, but in this case, 4 of a kinds. And pull everything out. So you pulled out a 4 of a kind of 2's, a 4 of a kind of x's, a 4 of a kind of x's. You left behind a 2 and an x, and again, you need a 4 there to show it's a fourth root, and then just clean that up. And you win. That's today's lesson. Okay, so whether you're doing square roots and you pull out pairs, or you're doing cube roots and you pull out triples, you do the same thing. Okay, the number tells you what to do. So if you could go to Canvas, try the assignment, simplifying radicals. It starts with square roots of just numbers, and then it works up to variables, and then it works in cube roots, and so on and so forth. If at any point you have any questions, shoot me an email, and otherwise I will see you later. Thanks.